Ever wondered how those moving images appear on your TV screen? It's a question that's been tickling the minds of curious folks for decades. But fear not, because today, we're going to unravel this mystery together. You see, a TV screen is not just a simple piece of technology, it's a magical canvas that paints pictures with light. Yes, you heard that right. Light. It's all about controlling and manipulating light to create the images you see on your screen. Imagine a massive crowd of tiny, energetic fireflies, each carrying a different color of light. Now, picture them all buzzing around in a coordinated dance to create a beautiful, dynamic image. That's essentially what's happening inside your TV monitor. Only instead of fireflies, we're dealing with pixels. Pixels are the smallest unit of a digital image. Think of them as the individual dots in a pointillist painting. Each pixel on your screen can display a variety of colors, and together they form the moving images you see on your TV. But how do these pixels know what color to be at any given moment? Well, that's where the magic truly lies. Each pixel is controlled by an intricate system of electronic signals. These signals tell the pixel what color to display based on the information received from the video source, be it your cable box, game console, or streaming device. So it's like a grand symphony of light, where each pixel is a musician playing their part in perfect harmony to create the masterpiece that is your favorite TV show or movie. But remember, this is just the most basic explanation. The true workings of a TV monitor are far more complex and fascinating, involving a series of rapid changes and adjustments that happen faster than the blink of an eye. So, at its most basic, a TV monitor is just a complex light show, and that's just the beginning. As we delve deeper into the world of TV technology, you'll discover the intricate details that make the magic happen. So, stick around, because we're just getting started. Now let's delve a little deeper into this light show and meet its main performers, the pixels. Imagine a grand mosaic, a sweeping tapestry of vibrant hues and subtle shades. Now consider that each tiny piece of this mosaic is a pixel. But what exactly is a pixel, you ask? Well, in its simplest form, a pixel is a minute area of illumination on a display screen, one of many from which an image is composed. Just like the individual tiles in a mosaic, each pixel contributes to the overall image on your screen. But instead of ceramic or glass, these pixels are made up of 3 subpixels, red, green, and blue. When these subpixels shine at different intensities, they can create any color you can think of. It's a bit like mixing paints, but with light. Now, how do these pixels work? Well, each pixel is like a tiny light bulb. When an electric current passes through, it lights up. The strength of this current determines the brightness of the pixel. So, when you're watching a movie or playing a game, your screen is essentially a dynamic dance of these tiny light bulbs, switching on and off, and varying their intensity. Interestingly, the human eye is unable to distinguish between the individual pixels when viewing from a typical viewing distance. This is why the images on the screen appear continuous and seamless to us. It's a bit like standing far away from a pointillist painting. You see a unified image, not the individual dots of color. But these pixels aren't working solo. They're part of a larger team, coordinated by a conductor, if you will, known as the Graphics Processing Unit, or GPU. The GPU determines which pixels light up, and when, to create the images you see on your screen. So, there you have it. The countless tiny pixels, each a combination of red, green, and blue, working in harmony under the guidance of the GPU. They light up, change intensity, and switch off on cue, creating the moving images we enjoy every day. So, the countless tiny pixels work together to create the images we see on the screen. Ever heard of the term refresh rate and wondered what it means? Let's dive into the world of pixels and frames to unearth the mystery. When we talk about refresh rate, we're referring to the number of times per second a display, like a TV or computer monitor, updates its image. Think of it as the screen's heartbeat. It's measured in hertz, which is just a fancy way of saying times per second. Now, why is this so important? Well, the refresh rate is fundamental in ensuring smooth motion on the screen. A low refresh rate might result in an experience similar to watching a flipbook, with each frame of the image appearing one after the other in a noticeable fashion. On the other hand, a high refresh rate, like 120 Hz, updates the screen 120 times per second, making the transition between frames smooth and seamless. This is especially crucial for fast-paced content like video games or action-packed movies. A higher refresh rate reduces the motion blur and provides a more fluid and immersive experience. It's like the difference between watching a bird glide through the sky or seeing a series of still photographs of the bird in flight. Surely you'd prefer the first, right? But there's a twist. Not all content is created equal. While a higher refresh rate is fantastic for gaming or action scenes, it can make slower, more dialogue-focused content look unnaturally smooth, a phenomenon often referred to as the soap opera effect. Moreover, there's a limit to what the human eye can perceive. Most people won't notice much of a difference beyond a refresh rate of around 120 Hz. So, while the numbers game can be enticing, it's important to consider what kind of content you'll be viewing most. To sum it up, the refresh rate plays a vital role in shaping our viewing experience. It's the invisible hand that guides the dance of the pixels on your screen. So a higher refresh rate means smoother, more realistic motion on the screen. Now let's talk about something we all love: colors. The vibrant hues you see on your TV screen aren't just random bursts of color. They are carefully crafted using a system known as the RGB color model. The RGB stands for red, green, and blue, the primary colors of light. By manipulating these three colors in varying intensities, we can create almost any color imaginable. Let's dive a bit deeper into how this works. Imagine your TV screen as a vast canvas, composed of millions of tiny light-emitting pixels. Each of these pixels contains three smaller subpixels, one for red, one for green, and one for blue light. By adjusting the brightness of each subpixel, we can control the final color that the pixel emits. For instance, when all three subpixels are at their brightest, the pixel will emit white light. Conversely, when all are dimmed, the pixel will produce black. All other colors are created by varying the intensity of each subpixel. For example, a full intensity red and green with no blue will give you yellow, while a mix of full intensity blue and green will give you cyan. This might sound simple, but when you multiply this process by the millions of pixels on a screen, you can begin to appreciate the complexity involved. Each pixel must be continuously controlled and adjusted to produce the desired image, from the deepest blues of the ocean to the fiery reds and oranges of a sunset. And it's not just about creating static images. With video, these millions of pixels must be updated and adjusted dozens of times per second to create the illusion of movement. It's a dazzling dance of light and color that happens so fast it's invisible to the naked eye. So next time you're watching your favorite show or movie, take a moment to appreciate the magic happening right in front of your eyes. Each scene, each frame, is a masterpiece of light manipulation, brought to life by the simple yet powerful combination of red, green, and blue. Therefore, the variety of colors you see on your TV screen is all thanks to the clever manipulation of red, green, and blue light. So, what's next for TV monitors? Well, the future of TV monitors is shaping up to be quite exciting, to say the least. As we move forward, technology continues to evolve and improve, promising to deliver an even more immersive and visually stunning viewing experience. One of the front-runners in this race towards the future is the OLED technology. Short for organic light emitting diodes, OLED is known for its ability to deliver deep, true blacks in a wider color range. This is because each pixel provides its own illumination, meaning when it's off, it's truly off, creating a perfect black. This not only improves color and contrast but also reduces energy consumption. Next up, we have the ever-evolving resolutions. You've probably heard of 4K and 8K, right? Well, these aren't just random numbers, they refer to the number of pixels on the screen. The more pixels you have, the sharper, crisper, and more detailed your image will be. Imagine having 8,000 lines of pixels from top to bottom on your screen. That's 8K for you. And let's not forget about quantum dot technology. This advanced tech uses tiny particles, or dots, that emit or alter light at different frequencies to produce different colors. The result? A much wider color spectrum and greater color accuracy. But it's not just about the visuals. Future TV monitors will also focus on enhancing the audio experience, creating a perfect blend of sight and sound. So we can expect to see more integrated soundbars and advanced audio features. The future is bright indeed, and the next generation of TV monitors is set to redefine our viewing experience. But no matter how much the technology evolves, the essence remains the same. It's all about translating those zeros and ones into a beautiful, mesmerizing light show for our eyes and ears. No matter how advanced TV technology becomes, it will always be about creating that perfect light show for our eyes.